1, 2, 3. When you say it like that, it sounds like a straight line, doesn't it? Like steps on a ladder. You learn your first language, probably as a baby. Then maybe you pick up a second one in school. And, if you're ambitious, you tackle a third. It feels like you're just adding another book to your mental shelf.
It does feel that way, but if you talk to the people studying this, the linguists, the cognitive scientists, counting to 3 is actually where everything kind of breaks down. It's a massive leap in complexity. It's not just second language acquisition plus 1. It is an entirely different beast with its own chaotic rules.
That is exactly what we are digging into today. We are looking at a deep dive based on a pretty dense, forward-looking chapter by Rothman and his colleagues. The title is a mouthful, The Future of Third Language Acquisition and Linguistic Transfer. But the content is wild. It's basically a roadmap for how our brains juggle multiple linguistic systems at once.
And this is really where the rubber meets the road. I mean, the source material is fascinating because it is essentially a manifesto for where the science needs to go next. For decades, the research has been a bit lazy. We looked at college students learning French and called it a day. This text is saying, no, we need to look at the messy reality. We need to look at children, at heritage speakers, and we need to look at what is actually happening electrically inside the brain.
So the mission for this deep dive is to figure out that messiness. We aren't just looking at how to conjugate verbs in Spanish. We're exploring how languages can actually bleed into each other, how learning a new language might, damage an old one, and what brainwaves can tell us about that elusive bilingual advantage.
And the source material frames this by asking the hard questions. Do the models we have for adults even work for kids? Can a new language rewrite an old one? And can we finally see this happening in the brain?
So let's start with the kids. Because when I think of language learning studies, I usually picture a 19-year-old in a psych lab, trying to earn extra credit.
That is a standard guinea pig for these studies, absolutely.
But the text argues that not all bilinguals are created equal. Most of the models we have are built on what they call sequential bilinguals. That's me. I learned English as a toddler, then I took some Spanish in high school. It's a timeline.
Right, it is a timeline. But linguistically, it's a very specific type of timeline. We treat it as the default, but this chapter argues we've over-indexed on that sequence. What happens when the timeline is messy? What if you are a heritage speaker?
You mean someone who speaks one language at home, like with their parents, but then goes to school in a completely different language?
Exactly. That changes the starting line completely. The question posed in this text is, does your specific background change how your brain tackles a third language? If you learn 2 languages simultaneously as a baby, does your brain build a third one differently than someone who learned them one by one?
And to answer that, the text points to a study involving kids in Germany. I think it was by Hop.
Yes, the HOP study from 2018. It is a crucial piece of evidence because it actually tested children, which is surprisingly rare in L3 theory. HOP looked at Turkish-German bilingual children living in Germany.
Okay, set the scene for me.
So these are heritage Turkish speakers. They speak Turkish at home, but they are dominant in German because, they live in Germany, go to German schools, watch German TV. And now at school, they are learning English as their third language, their L3.
So they have Turkish and German just rattling around in their heads, and they are trying to squeeze English in there too.
And Hobb set up this linguistic puzzle involving word order to see how they would handle it. This is where we have to get a little technical, but bear with me because it's really cool.
I'm ready. Break it down.
Okay, so think about how we build a sentence in English. We usually follow a subject-verb-object pattern. SVO, I eat the apple.
Simple enough. I, the subject, do the action to the object.
Right. Now, Turkish is completely different. It is SOV, subject, object, verb. So in Turkish, you would essentially say, I, the apple, eat. The verb always hangs out at the very end.
Okay, so English wants the verb in the middle. Turkish wants the verb at the end.
Now throw German into the mix. German is the tricky one. In a normal main sentence, it has a verb second, or V2 rule. The verb likes to sit in the second spot. I eat the apple. But, and this is a bit but, if you make it a complex sentence or a subordinate clause, the verb runs to the end of the line.
Wait, really? It moves just because the sentence got complicated?
It does. If you were translating literally from German, you might say, I think that I, the apple, eat.
That sounds exhausting.
It's a complex system.
Yeah.
So you have these kids, their brains are holding on to a verb middle system from English class, a verb end system from home, Turkish, and this weird verb moves around system from German. The question Hop asked is, when they try to speak English, Which map do they use?
My gut tells me they would use Turkish. I mean, if that's their home language, isn't that the deepest one?
That is what you might expect if mother tongue was the deciding factor. But the findings were different. The children transfer the German grammatical structures into their English.
They use the verb second rule.
They did. And here's the kicker. They did this regardless of whether they were more dominant in Turkish or German at that moment. Even the kids who spoke a ton of Turkish at home still used the German template to build their English sentences.
Why? Is it just because they live in Germany and hear it all day?
Well, the study suggests it supports something called the typological primacy model, or TPM. The idea is that the brain is a pattern-matching machine. It analyzes the structure of the languages. It realized that German and English have some structural similarities, or perhaps simply that the German system was the most viable parser or template available to them for this specific task.
So the brain is looking at English and saying, this looks a lot more like German than Turkish, so I'm going to use the German instruction manual.
Basically, yes. It wasn't about, I learned Turkish first, so that is my base. It was about, which tool in my toolbox fits this job best?
That is huge. It implies that kids aren't just soaking up language like sponges. They are doing high-level structural analysis, just like adults.
It supports the idea of full transfer, that we don't start from scratch with a new language. We copy-paste an entire grammatical system from a language we already know to help us get started. And in this case, the structural properties of German won the battle.
So we've established that your old languages help build your new one. That's progressive transfer moving forward. But there was a section in this text that honestly unsettled me a little bit.
I have a feeling I know which part you mean.
We tend to think of learning as a one-way street. I learn Spanish, I keep it. I learn French, I keep it. But the text talks about regressive transfer, the backward ripple.
Yes. This challenges a very old, very comforting idea in linguistics called the steady state.
The idea that once I'm fluent in a language, it's locked in a vault. It's safe.
Exactly. Generative scholars often assume that once a system is acquired, it is stable. But this chapter argues strongly against that. It suggests that learning a third language can actually, well, attack and rewrite your previous languages.
That is the scary part. It's not just adding a book to the shelf. It's like the new book starts rewriting the pages of the old ones. The text mentions a few studies, but there was one specific case involving Portuguese that really threw me. It suggested that learning a new language can actually break a language you already know.
You're thinking of the Cabrelli-Amaro study. That is a critical piece of evidence. They looked at Spanish-English bilinguals who started learning Portuguese as a third language.
Okay, so they know Spanish and English, and they are adding Portuguese. What was the linguistic trap?
It was a feature called subject-to-subject raising.
Okay, subject-to-subject raising. That sounds like a corporate promotion. What does that actually mean in a sentence?
It's about how we structure opinions or observations. So in English, you can say, John seems to me to be intelligent. You take John, the subject, and you raise him up to the front of the sentence.
John seems to be intelligent. Okay, that sounds normal.
And Portuguese allows this structure too. But Spanish does not. In Spanish, you cannot construct the sentence that way grammatically. It just doesn't work.
So English and Portuguese say yes. Spanish says no.
Here is the twist. They compared two groups of people learning Portuguese. Group A was L1 Spanish native Spanish speakers who learned English later. Group B was L1 English native English speakers who learned Spanish later.
So both groups know Spanish, but for one group it's their mother tongue, and for the other it's a learned language.
Correct. And they are both learning Portuguese now. The study found that for the group who learned Spanish as a second language, the Portuguese started infecting their Spanish. They started accepting those John seems to be sentences in Spanish, even though they are wrong.
Wait, so they spent years learning Spanish correctly, but the moment they started learning Portuguese, their brain got confused and overwrote the Spanish rule.
Yes. The L3 Portuguese rewrote the rules for the L2 Spanish.
But what about the native Spanish speakers? Did they start making mistakes too?
No. They held their ground. Their native Spanish wasn't affected.
So if Spanish is my native language, I'm immune. But if I learned it later in life, it's vulnerable.
Essentially, yes. This leads to the differential stability hypothesis, or DSH. The hypothesis is that an L2 system, a language you learned later in life, is inherently less stable. It's more vulnerable to being invaded and rewritten by a new language than your native L1 is.
That makes intuitive sense, I guess. My native language feels like bedrock. My second language feels a bit more like scaffolding.
That's a great analogy. The L2 is structurally weaker, so when the L3 comes in with similar rules like Portuguese and Spanish being so close, the L3 can actually destabilize and change the L2.
So the scaffolding gets blown around by the wind of the new language.
Exactly. It's unstable.
But flip that logic for a second. If the L2 is unstable and easy to change, doesn't that make it easier to fix? If I'm making a mistake, wouldn't I want that scaffolding to be loose so I can take it down and rebuild it?
That is a brilliant observation. And that brings us to the concept of entrenchment.
The struggle to unlearn.
Right. We look at another study by Cabrera-Amaro and Iverson. It asks the flip side of the question, if languages transfer, how hard is it to get rid of that transfer when it's wrong?
So if I accidentally paste a rule from an old language into my new one, does it stick?
Well, that depends on where you pasted it from. They looked at Spanish-English bilinguals learning Portuguese again. This time, the problem was differential object marking, or DOM.
That's the personal A in Spanish, right?
Correct. In Spanish, if the object of a sentence is a specific person, you have to add the word a. You don't say, I see Juan, you say, veo a Juan.
But Portuguese doesn't do that.
No, neither does English. So if you are a Spanish speaker learning Portuguese, your instinct is to add the a where it doesn't belong. You are making a mistake based on your previous language.
Okay, so who fixed the mistake faster? The native Spanish speakers or the ones who learned Spanish later?
The learners who had transferred the mistake from their L2 Spanish were able to overcome it. They realized, oh, Portuguese doesn't do this, and they deleted the personal a from their grammar.
And the native Spanish speakers.
They were stuck with it. They kept making the error much longer.
Wow. So because Spanish was their L1, that rule was so deep, so entrenched, that even when they tried to speak Portuguese, they couldn't turn it off.
Precisely. We have massive cumulative experience with our L1. It is dug in deep. The neural pathways are thick highways. L2 representations are weaker. They're less entrenched, which makes them easier to override when they cause errors in the L3.
So the instability of the L2 is actually a double-edged sword. It means your L2 can be corrupted by a new language, as we saw with the subject raising, but it also means bad habits from your L2 are easier to break.
That is a perfect synthesis. The L1 is stable, which protects it from being changed but makes it a stubborn source of errors. The L2 is unstable, which makes it vulnerable to change, but flexible when you need to correct a mistake.
That is incredible. It really highlights that knowing a language isn't a binary thing. It's about the depth of those neural grooves.
And speaking of neural grooves, we need to talk about the frontier that the source is most excited about. Because everything we've discussed so far, mistakes, transfers, that's all behavioral. That's looking at what people say.
But the text says we need to look at the brain itself, the sci-fi portion.
Exactly. The source emphasizes that L3 research has really lagged behind L2 research when it comes to brain scans. We have lots of behavioral tests like fill in the blank, but fewer studies looking at the actual electricity in the brain.
But there's one study mentioned that starts to bridge this gap. Gray et al., 2017. And I have to admit, when I read the methodology, I thought they were joking.
You mean Brocanto too?
Yes, Brocanto too. You can't just gloss over that. Did they really invent a language just to test this?
They did, and it's actually a genius move. I mean, think about it. If I test you on Spanish, I don't know if you're struggling because of the grammar or because you just forgot the word for library, or maybe you heard a song in Spanish yesterday that primed you. It's messy.
Too many variables.
Exactly. With Brocanto 2, it's a level playing field. It's a chess game where the researchers invented the pieces. It's a miniature language with a tiny vocabulary and very specific grammatical rules designed just for the lab.
So they have these people, some bilingual, some monolingual, learning this fake robot language, and they test them.
Right. They taught this language to Mandarin English bilinguals and English monolinguals. Now, if you looked at their test scores, their behavioral results, both groups performed about the same. They both learned the language.
So on paper, no difference. The bilinguals didn't seem smarter.
On paper, no. If you looked at their report cards, they are identical students. But they hooked them up to EEG machines to measure event-related potentials, or ERPs. They were looking for a specific brainwave called the P600.
What is the P600?
Imagine your brain has a specific alarm bell that only rings when it hears bad grammar. Like a syntax siren. When you hear the cat are on the mat, your brain spikes with electrical activity about 600 milliseconds later. That's the P600. It's the brain attempting to repair the structure.
And what did the scans show for the people learning Brocanto 2?
The bilinguals showed this P600 effect at much lower proficiency levels than the monolinguals.
Let me make sure I get this. Even though they got the same score on the written test, The bilingual brains were reacting to the grammar errors sooner.
Exactly. The bilingual brain was engaging with the grammar on a deeper, more automatic level, much earlier in the learning process. The monolinguals, their brains were treating it more like a memory list. The alarm didn't go off because the system wasn't online yet.
That is actually kind of validating. It means even if I feel like I'm failing at a new language, or if I'm not testing well, my brain might be doing heavy lifting that doesn't show up on the quiz yet.
It provides biological evidence for the bilingual advantage. Even if they get the same score, the bilingual brain is tuned to handle multiple syntactic systems. It spots the pattern and the violation of the pattern faster.
That is wild. It's like they have a better grammar spell check running in the background.
And this is where the source material points to the future. Rothman and his colleagues propose a new methodology, what they consider the holy grail of validation.
This was the mini grammars proposal.
Yes, it takes the Brocanto 2 idea a step further. The proposal is to create fake versions of Spanish and English mini-grammars with just a few nouns and adjectives and hook people up to EEGs while they learn them.
Why go to that trouble? Why not just use real Spanish?
Because right now, in the field of linguistics, we're having a war over different models. Is it the typological primacy model? Is it the L2 status factor? We are arguing about why transfer happens. By controlling the input perfectly with these mini-languages and watching the brain waves like that P600 or the N400, we could finally settle the debate. We could see exactly which language the brain is transferring from in real time.
It's taking the guesswork out of it. Instead of asking someone, why did you say that? You just watch their neurons fire.
Precisely. It moves the field from observing behavior, which can be misleading, to observing the mechanism of thought itself.
So let's bring this all back home. We have covered a massive amount of ground today.
We certainly have.
We started with the idea that 1, 2, 3 is deceptively complex. We looked at Hop's study and learned that child L3 learners aren't just blank slates. They transfer grammar based on structural similarities, just like adults do.
And we learned about the backward ripple. Learning a third language can actually destabilize and rewrite your second language because that L2 scaffolding is wobbly.
But thanks to entrenchment, your native language is stubborn. It's hard to change, which protects it from being overwritten, but it also means mistakes coming from your L1 are the hardest to break.
And finally, we saw that the bilingual brain really is different. It lights up with that P600 grammar check signal earlier than a monolingual brain, proving that previous language experience physically alters how we process new information.
It really changes how you view learning. I think a lot of us think of learning a language as filling a bucket. You pour the words in, and they sit there.
But it's not a bucket. It's a chemical reaction. Every new ingredient you add changes the composition of the whole mixture. Your L3 changes your L2. Your L1 fights back against the L3. It is a dynamic, living ecosystem.
And that leads me to a final thought to leave our listeners with. The source material talks a lot about syntax being resistant to change. But the evidence we discussed, regressive transfer, brainwaves, shows that our brains are constantly editing our past.
That's a fair assessment.
So if learning a new language physically alters how you process your old ones, is your native language ever truly safe? If you learned enough languages, could you fundamentally alter the bedrock of your mother tongue without even realizing it?
That is a question that keeps linguists up at night. And if this research continues, we might find out the answer is no.
Something to think about the next time you open that language learning app. Thanks for listening to The Deep Dive.
See you next time.